Okay, this is W5HRO. Hey, I got the T368 exciter mounted on that panel and relay rack properly. Look, I got the rectangle hole cut out. It's all mounted flush. I still got to add the screws here with nuts on the other side, but that's later. I mainly got it mounted in there. I got it centered up like I want it, and it's mounted good on the relay rack. So that was the hard part. Now I have enough room to build the supplies on this side. And I might put a small voltage meter there with an adjustment for the negative peak limiter supply. And I did actually find, if I get my fingers out of the way of the camera here, I did find my old circuit that I drew up for the keep-alive supply for the negative peak limiter. See, there's the modulation transformer. There's the 2 resistor, 3 diode negative limiter. And what I have here, this is supposed to be a 10K. I never did update this schematic. I have 2 10Ks to give me 5K. My plate load is about 6.3 something, but for the negative peak limiter, 5K is adequate, because when it comes down the negative peak, both of these resistors are in parallel. Trust me, you want this extra resistor. You want to divide this resistor. It would normally be, whatever your PA plate load ohms is, right? But basically you divide it in half and you add another one here, the same value, so when it goes down, these two are essentially in parallel. This resistor here solves a problem that happens with this diode. There's a flaw in the original circuit. The original circuit was used back in like the 50s. I mean, there were guys building these things with the 866 mercury vapor rectifiers. They were using 872s. This circuit's been around for years, just not with the other resistor. And I discovered the problem on this diode here. It hits a brick wall, which creates a lot more splatter on the band than you don't know it's there. Plus, it blows the diodes. There's this myth that using fast diodes is the answer. That's got nothing to do with it. There's a flaw in the sequence of events in the overall timing when you're modulating. There's a problem with this diode. And unless you put this thing on a spice simulator, you will not see it. You have to look at the current going through the diode. And it's an obvious mistake. And adding this resistor, it bridges it over at the right time interval to solve the problem. It does so it eliminates it, and it works, and it keeps you from blowing the diodes. Going to super fast diodes is not going to solve the problem with this diode here. I'm telling you, it won't, and there's a reason for it. But what I was going to do is I didn't want to just leave this keep-alive supply on all the time, because it's going to put a small voltage on the plate of the RF tube, right? I mean, you don't really want to do that. Or it's going to go up through this way, that way to the tube. But I want it to come up faster than the actual plate supply for the modulator and the RF deck. So what I've got is I've got a DC solid state relay, and I am going to try to make this work. This is not an AC relay, this is a DC. It's 1000 volts DC. See the line with the 3 lines like an S, like Morse code? Oh, wait a minute, S is 3 dots, right? That shows you how rusty my code skills are. I don't think I could pass 15 words a minute again if I tried. Or what was it, 13 back then? I was up to about 15 when I passed to 13 years and years ago. But you can see that's 1000 volt DC. That's not an AC symbol. So it's a 25 amp relay, and I'm going to use this to turn on the keep-alive supply. And since it's a solid state relay, it should come up faster than the plate supply, so that should be okay. That should be adequate, because I want this to come up and stop before the plate supply is fully on, and that's exactly what you want. But this is a soft limit plate supply, believe it or not. I mean I'm sorry, I don't mean plate supply, keep-alive supply. This is a soft limit design, and it will work. It will in fact work. It'll soft limit the whole thing, so it does both. So this is what I'm probably going to build up, and I had what, a 5U4, is that a 5R? 5U, I'll just put a 5R4 in there. But that's what I was going to do for the keep-alive supply, and that's probably what I'm going to build up on the back end of this rack. And like I said, I might put the meter there for the voltage, because I'm going to need around 200 volts. I'm estimating around positive 200 volts for the keep alive supply, plus or minus 50 volts. So I just need something that adjusts from about 200, I mean about 250 maybe like between 300 and 150 or something, you know. That's all I need. I just need some kind of adjust to tweak it up. It's probably going to be right. It's going to be somewhere around 200 volts because I'm shooting for about a 90% negative peak max, and with my plate supplies, that's going to be around 200 volts on the keep alive supply, maybe just a little more. So, but this supply will actually soft limit the whole thing, so it's the right type of design for it. So that's what's going to go in here too. So what I'm going to do next is I'm going to go out in the garage and I'm going to pull off these old transformers and these chokes, and I'm going to reuse a lot of these components, the tubes and the chokes and all that stuff, except these rectifiers. I may use a couple of them on the to regulate the T368 because I need 150 volts regulated on one line. By the way, I did find, you know what, I took it out in the garage. Let me go out there and let's look at that real quick. It's dark here. Dark. But I did find my schematic, and here we go. See, there's the some of the main connections. Basically, the connector on that, the power connector on that exciter is P101, and these are the pins here. And this is what the pins do. 1 and 2 is the 6.3 volts for the filaments. Pin 3 is plus 150 volts regulated. The 4 and 5 is the filament voltage for the 6000 tube. Then pin 7 is the B positive for the multipliers. It's supposed to be 275 volts. Pin 8 is supposed to be minus 55 volts. Pin 9 is supposed to be the plate for the 6000 tube, about 370, 375. I think my transformer is like 375. And 13 is ground. And that should be the majority. There is another one, pin 6. I don't know what that one is. I got to trace it down in the other schematic. Some of these I don't think you even need. It gets powered up another way, but I just need to make sure I do have grid voltage on this 6000 tube grid, the control grid. So that's what I got to be, because that actually hooks to it. See, pin 6. So I've got to figure out what that connects to. It may just be okay to leave it open, but I'm not positive. But these are the main ones right here. So I did figure all that out. Somebody sent me some information and I added on to it. So making progress, but that's what I've got to have for the exciter supply. I've got to have 275, 370 or 375, then 150 regulated on pin 3, then two filament voltages. That's actually quite a bit of stuff. I mean, that's going to require probably more than one transformer, because the one I've got, it won't do the 26.5. Now, the tube has a min-max of what, like plus or minus 2 volts or 2.5 volts. So if I put a 24 volt regulator, I don't have to have a regulated supply, but if I take a 24 volt transformer, maybe one that's a little higher current than what I need for the 6000 tube, if I can find it on the schematic there, then maybe it'll load it down to where it'll be right at, 26 volts or so. But 24 volts will work. A 24 volt transformer will work fine. If I just find one that's a little more current than what I need, so the voltage will be a little higher, that should solve that problem. So that's it for now. This is W5HRO.